Hey guys, welcome to the Software Engineering channel. I know it's been a moment, but I think the break was worth it. However, in today's video, we're going to be looking at the later part of ISO 8583. My intention is to actually wrap this subject matter up because I'm so eager to share other new things that I've been working on, other new findings, new subject matter that I think might interest you. But we need to wrap this up. So we're going to be looking at the bitmap section. Remember, we're trying to analyze what an ISO message consists of. And if you don't know anything about ISO 8583, you're going to get a little bit lost in this particular video. So I'd advise that you check out the previous videos that we've done on ISO, so you can have a mental model of what we're trying to talk about. So we're going to be looking at the bitmap section, and we're going to be looking at the data elements. Right, every ISO message contains, most importantly, data elements. That's where you have your processing codes. That's where you have your details like tran code, like your stan, your amount, and the likes. So we're going to be dissecting all of those, looking at bitmaps. We're going to be looking at data elements. How do we know what a message stands for? How do we know what the message is meant to do, and how are we able to interpret an ISO message? That's what we're going to be looking at. And the later part of this video, we're going to be going into a practical section where I will show you how to actually derive an ISO message in code. After deriving that ISO message, I'll show you how to also analyze all of those messages. So you can see in real time the meaning of those messages and what they actually stand for. How about we dive right in, guys? So your bitmaps are basically an indexing technique used in ISO 8583, right? If you've ever done anything called, I'd rather use a difference. If you've ever done anything called array, you would understand what the word indexing means. All right, and that is what bitmaps basically are. They are basically indexing um, technique used in ISO 8583 or any ISO at all. But since 8583 is our version of choice, we're going to be centering everything we're going to be talking about to 8583, right? So if you've ever done anything that has to do with an array, you would understand what indexing is. So when you have something like this, all right, you know that your index starts from 0, and then you have your 1, you have your 2, and then you have your 3. This is what we call index. This is not the original value, all right? These are indexes that point to the location of the original value, and that is exactly what your bitmap does. Excuse me. Your bitmaps are basically an indexing technique that is used to depict um, if a particular data element is present in an ISO message. I repeat that again. Your bitmaps are basically an indexing technique that is used to depict or tell, if you will, if a particular data element is present within an ISO message. All right, so I'll give you a quick example if that was too mouthful for you to grab. Okay, so for example, let's say we have this. So 1, 0, 1, 0, 1. Now let's say this is what we call a bitmap. Now what I'm saying is that this being called a bitmap is used to tell which data elements, which we're going to be talking about next, exist within a particular ISO message. Let's say this is an ISO message. All right. So if you have this bitmap element, you can tell which data element is present within this particular ISO message. And the way it works is your bitmap can only be zeros or one. They are basically binary. Yes, you can have them in hexadecimal and the likes, but at the end of the day, for them to be effective, for you to actually use them, you have to convert them to binaries, and you see how we do some of those. You convert them to binary, and since you're going to have zeros or one simply means that data element is present within the message, and zero simply means that data element is not present within a message. Right. So basically, an ISO message, remember we said an ISO message would usually contain, the first part would usually contain an MTI, and the second part would usually contain your bitmaps. So when you see this particular section, when you see the bitmaps in our case now, 0 and 1, with this particular bitmaps, you can tell which data elements is contained within this message. This is the real message. All right. But with the bitmap, it's basically like, as the word implies, a map. Right. So with this, I know that if I can successfully read this bitmap, I can tell which element is contained within my message. All right. And some of these elements has predefined meaning. Let's quickly look at that very quickly. Let's look at that very quickly. Any ISO message must contain at least one bitmap, right? Must contain at least one bitmap, which is called the primary bitmap. Any ISO message at all should contain at least one bitmap. It can contain more. We have the primary bitmap, we have the secondary bitmap, and we have the tertiary bitmap, but it must contain at least the primary bitmap. And as funny as it sounds, the first bit, so let's say we have bit 1, the first bit of any bitmap, all right, the first bit is usually used to tell if a secondary bitmap is contained within an ISO message. That's what the first bit does. So the first bit is used to tell if the secondary bitmap is contained within an ISO message. So when you see any bitmap, in our case, let's say we have something like this, 110 1. When you see any bitmap, this first bit is what tells you if we have a secondary bitmap within that message or not. All right. So if this, in our case, this is set to 0, it means our message does not contain a secondary bitmap because this is set to 0. All right. And the second bit, the second bit is used to tell if we have um, a account, primary account number, which is well known as your PAN. That's what the second bit tells, right? So this second bit in our case is used to tell us if a PAN exists within our data elements, within our message. All right. In our case, because this is set to 1, remember this is just like I can't remember now, but when you have 0, 0 means off. All right. When you have 1 means on. That's basically what we are doing here. Logic, if you will. Right. Let's clean this off real quickly. So this is used to represent your PAN. So this tells us if PAN is present within the message or not. And we also have, for the want of space, let's just wipe this off. I'm going to manage the space real quick. So we have bit 3 as well. Bit 3 is used to depict the processing code. Bit 3 is used to depict the processing code, which in our case is this guy, right? So you can just call this pro code. And the processing code is um, something like say deposits, withdrawal, inquiry, balance inquiry, and the likes. That's what the pro code tells. So with the processing code, you can tell what action the ISO message wants to perform. That's basically what it is. And the third bit, which is the third field, is used to tell you if the processing code is contained within the ISO message. And let's look at the last one. Not the last one, basically. That's bit 4. Just gonna do that here real quick. Bit 4 usually contains the amount or trans. So bit 4 contains the amount or trans. All right. So in our case, this is our bit 4 or field 4, if you will. This is our field 1, field 2, field 3, and field 4. Now, field 4 contains the amount. Now, because this is set to 0, it means within our ISO message, the amount is not contained. Does that even make sense? It means within our ISO message, we do not have the amount data elements. All right. And if you do not have it there, it means you do not need it. For example, if you are sending a request to a bank saying you want to get a balance inquiry, you do not need to send an amount. All right. So in that case, you do not need an amount to be present within the message. And if you check your bitmap, you would have already seen that amount says 0. It means an amount is not contained within that message, right? The reason why all of this would help is because if you are actually starting to write the program as a developer, you can use your bitmap to tell which elements you should look out for within your data elements. That's actually what all of these are. And that's why your bitmap is actually very, very important. All right. And this spans all to up to about bits, bit 64. All right. So your primary bits is usually from 1 to 64. And I think your secondary bits, that's your secondary bits, is usually from about 64 to 120, if my memory serves me right. And you also have your tertiary bits, which is usually from I think 121 to 190 bits. My memory serves me right, but you might hardly use those, right? I think the more important one that you're going to use often would be your primary bits. All right. Yeah. So basically, that's all you need to know about bitmaps. The bitmaps are basically indexing technique used by ISO 8583 to tell which data elements are present within your ISO message, and with that, you can determine which elements you should look out for. And remember that it's usually 1 or 0. Even when you have the value in maybe hexadecimal or any any particular conversion type that is not binary, you can easily convert them to binary because you need the zeros or one to tell if the element actually exists or not. I hope that makes sense to you. Let's quickly flip into data elements and see what data elements means. And from there, we quickly jump into seeing the practical aspect of all of this. So your data elements are basically the fields carrying the information for transaction purpose. And when it comes to data elements, the original ISO 8583 has about 128 data elements. That's the 1987 version, and the later version has about 190 and above. Data elements are usually different. They are varying in one. They are varying in field type, and two, they are varying in length. I think that's the most important category that you can use to categorize your data elements. Basically, what this means is you can have data elements that are fixed, that have fixed size, and you can have data elements that has a varying size. Varying size. For this, you would usually see things like L var, you would see LL var, you see LLL var, and the likes. And for this, which are basically the types, we have numerics, we have alpha, we have special, we have special characters. And you can actually combine all of this. For example, if you combine this, we have alphanumeric. If you combine this, and this, you have alphanumeric special. If you combine this and this, you have numeric special. If you combine this and this, you have alpha special. So yeah, so you would usually have your data elements that could be, for example, your MTI is, for example, your MTI is usually an N4. So what this N4 means is, and also I should say, numeric is represented by N. Alphanumeric is represented by a He, and this is represented by S. So this is telling you that your message type indicator as a data element has a numeric of fixed size, and the fixed size is 4 length. All right, that's what that means. And so you're going to be saying a lot of things like that. So what I want us to do now is to actually get into code and see how all of these things actually pan out. We're going to format a full and real life actually. We're going to format a real life example of an ISO message, and then we'll take it to a parser online that breaks down this message, and then we see the different paths of the things that we've been learning, so we can just have more like a mental model of what we've been learning theoretically in code. Let's get into code. So this is what we have. This is just basically a demo project that is basically going to be showing um, how ISO message can be crafted. I have some libraries here already. There is a particular library that helps me do the heavy lifting of um, formatting ISO message and the likes. And to be honest, you would really not have to perform the heavy lifting of conversion and the likes. There are a ton of libraries out there that are actually going to make your life much easier and simpler when it comes to crafting the message, all right, that you can consume. For example, I have this particular library that I use. um, you only just want to make sure that it uses the particular ISO version that you are using. So as long as it uses that same version, it's everything within it is going to follow that particular standard. All right. So there's nothing to be scared of. So this already does the heavy lifting for me. All I just need to do, as I'll show you now, is to basically define all of the fields that I want to be set within my ISO library, and then pass them into the data elements and build my new message. All right. So this is what I'm going to be showing you. So this is a real life example. All right. You can see that the first thing I'm doing is setting my is defining a variable for my message type indicator. And this obviously means a financial, no, this is not a financial message. This is an authorization message. This is an authorization message. 0100. You can check out the previous tutorial on message type indicators to understand what this is if you do not. And we have a primary account number, which is already set here, um, which is usually contained within the second data element. You have your pro code, which is your processing code. Um, we have the amount, we have the date and time, we have the stand, system trace, audit, we have the expiry dates, we have the merchant type. This is actually a real life authorization. And what is happening here is that an authorization request is being sent from the acquirer to the card issuer. All right. So the acquirer probably wants to withdraw some money from his card using his card or maybe a POS terminal. So the acquirer card or POS terminal is issuing an authorization. Should I grant this guy access to perform the withdrawal request that he wants to make? That is what you're seeing over here. So we have the POS entry mode. Was it swiped? This obviously means a swipe card. And the meaning of all of these things is usually defined to you, right? You would have a document that contains the meaning of all of these things. And it will be easy for you to know what exactly you are to pass. So I created an instance of my ISO 8583 library, and I told you that data elements are basically just an array of fields that carries the information that you actually want to transfer. So the next step, which is the third step, is to start assigning the fields to the data elements. You already know that the first element is usually your MTI, and the second element is usually your pan, and it goes on and on like that. All right. And the next thing obviously is to build the ISO message. All right. So let's run this and see what we have. Okay. So you can, let me see if I can increase this. You can obviously see the ISO message that was built. So the beauty of this is that what you see here is actually what gets transferred from the POS terminal down to the card issuer. This is what gets transferred over the network. This is beautiful, guys. So what we'll do is to copy this and then go to an online parser. Um, and don't worry, I'm going to leave a link to this particular code snippet so you can have a look at it afterwards. So I'm going to use this online parser. I'm going to pass, I'm going to paste my generated ISO code, and I'm going to pass the message. And what this is going to do for me is to break down my message and show me what my message actually means. And you can see it's doing a great job at that. So the first thing it shows you is it shows you obviously your ISO message, and it shows you your message type indicator. And you can see that our message type indicator in this place is 0100, which is this guy over here, 0100. And this tells you what the message type indicator is. The 0 stands for this, 1 stands for this. We treated all of this, right? And it combines it together to tell you what exactly this message wants to do. So you can see here that this message is an authorization request from the acquirer to the card issuer. This is beautiful. And the next thing it does is to show you the bitmap, all right, the primary bitmap. And we already established that after your MTI, the next thing you have is your primary bitmap. And that's what you have here. And you can see that here, this is your primary bitmap. And I already also established that your primary bitmap has to be converted to binary. All right. So that's basically what we have here. This is the value converted to binary digits. And with these binary digits, every zeros that you see here means that the element is not contained within the data element. And every one means the element is contained within the data element. And the only element that is going to be contained within the elements, within the message, are the elements that we have set. All right. And the only element you're going to have are these elements that we have set over here. All right. So that's why you have a lot of zeros and you have ones, right? And let's go to the next. Secondary bitmap. Secondary bitmap is not present. And obviously, we said the first bit of your primary bitmap tells you if your secondary bitmap is present or not. And with this is a 0. So it obviously tells you that the second bitmap is not present. And now what this also does is to do a beautiful job of showing you all of the data elements that was detected. All right, so these are all of the data elements. And if you check this side by side, if you check this side by side with our code, you will notice that it is actually very correct. All right, so we have the pan, which is we have the processing code. We have the processing code, which is the third element. All right, that's the processing code. We have the fourth element, which is your amount. We have the amount. We have this, and you can see the field type. All right, so this is a numeric field of fixed length. All right, numeric field of fixed length. You can see an AN. An AN simply means alphanumeric, right? And you have ANS. ANS simply means alpha numeric and special characters. All right, so this is beautiful, guys. This is beautiful. This is beautiful. So this is what gets sent to the ISO server. So the idea is the issuer, the card issuer, which is usually your bank, would usually have an ISO server that is listening for, that is listening, that has a connection opened and is listening for messages such as this. So the ISO server would obviously transcribe the message, decode the message, and in this case, it's actually going to pass back an authorization response to say, okay, this guy is an authentic user and this user can legitimately make withdrawal or do whatever it is they want to do. All right. So that's basically it. I'm going to leave a link to this particular website below so you can just play around and see what you find. We're going to just cap it up over here. I'm not sure yet. Um, Depending on what you guys want. If you want us to have an ISO server, build an ISO server and have the ISO clients actually send the message to the ISO server, and we see the ISO server in real time receiving the message and also transcribing the message and sending the request back. That can be fun to do. I don't have intentions to do that, but if the request comes forth, I can think about it. But for now, I think I'm just going to be capping ISO 8583 over here. Um, do well to subscribe and turn on the notification bell so you can get notified of the next video. And also, I'd like to see your comment. All right, I'd like to see your comment on this particular subject matter. Let me know if it was helpful and let me know if you're currently building something that has to do with this. Till we meet again, guys. See you on the next one. Cheers. Bye.